So now I'm going to introduce a topic that seems like a detour, but actually relates a lot still to our topic of classes. And that topic is type casting. For the entire course so far, we've kind of glossed over the fact that types are very, very important in Swift. In fact, you really can't ever mix types together. It's really hard to in Swift. Some things that are easily done in other languages, such as adding floating points together with integers and together with doubles, are very seamless in some other languages, like C. But in Swift, because those types don't match exactly, they don't match at all. And so you have to do the work to convert those types around. We've seen a little bit of this before when we cast things to double and so forth. But I'm going to be very specific in showing you an example of this. So let's just say we have x equals 3. And let's just be real explicit. Let it be a double. Y be an integer, 4. If we then try to print out x plus y, we get an error. Binary operator plus cannot be applied to operands of type double and int. Okay, so this is for especially those of you coming from C or some other language, Perl. Swift is a very anal language when it comes to types. There is no implicit type conversion, even for things like adding together doubles, floats, and ints. Okay, so if that doesn't convince you, just remember in Swift you have to always be very explicit with what types you're working with. And so what happens if you're trying to do something like this where the types don't match exactly, but yet you should be able to do something? Well, the answer is you have to explicitly, not implicitly, do the conversion yourself. That is, you have to actually make that conversion happen, not allow or rely on the compiler to do it for you. So what you would do here is call a constructor for the integer value, say, call the double constructor on the integer value. And this will create a double from this int. Okay, so you're basically calling this function to do a conversion. And then at this point, these two types now add up to the same one. They're equal. So when you add the values together, you get the number you expect, which is 7.0. And notice it's 7.0 because you've now created a double result, not an int result. Okay? So this is just very fundamental type casting that we're doing here. We're casting a variable of one type into a variable of another type. We're converting it. And so this type casting is something that you really have to be careful of in Swift, and you have to do a lot because it does not do any implicit type conversion for you. Now, how does this relate to classes? Well, in particular, it relates to the way subclasses and parent classes relate. Okay? So go back to our example here where we have an array that we've built up in one part of the code, right, of various shapes. And then another part of the code, we just have this array of shapes, but we don't know what actually was done to make them up. We don't even know what's inside them. We just know that they're shapes, but we have no idea what kind of shape specifically they are. Well, in addition to relying on overriding methods to get very specific behavior run, we can also do type casting. So let's say we know that a given shape is indeed a rectangle. So just for a moment's sake, we could say we know the very first one is actually a rectangle. Okay? Well, we can actually check for this first using the is operator. Sure enough, it is. So the is operator will actually check to see if a class is of a type that is of a subclass of this other type. Okay? So you have these two types, one on the left and one on the right. Is checks to see that the type on the left is indeed equal to that of the one on the right. And this type on the right must be a subclass of whatever type this variable is on the left. Okay, it won't work otherwise. The compiler will complain. So that's a very powerful thing to be able to do, because in the code you can check and see and make conditional behavior based on stuff at the subclass level, even when you have a very generic container of objects like this. Now, once you know for sure that you have a subclass, you can then explicitly typecast that down using the as operator. So, whereas before in our double and int conversion example, we just called the double constructor, the way it works for subclasses is you use the as operator. And specifically, there's actually two versions of as. There's as question mark, and then there's as exclamation point. Okay, as question mark gets into another subject we will not cover until a little bit later called optionals. Okay, so for now we're going to table that, but we can still use the as exclamation, and this can only be used. It should only be used when you're really sure that this conversion will work. Okay, so I would recommend for now just throw an if statement like this using the is operator first. At that point, you know for sure that the as exclamation operator will indeed work. So the code would look something like this. And at that point, you now have a rectangle, okay, that you can do rectangle things on. So that is the power of type casting in Swift.